Hello and welcome to Season 3, Episode 9 of Logicast, the AWS News podcast brought to you by Logicata. I'm Karl Robinson, CEO and co-founder of Logicata, and I'm joined today, as always, by my colleague, lead cloud engineer, John Goodall. How are you doing today, John?
What would you do if I wasn't always here? How would you do? How would you cope?
I'd just skip the episode and wait until you come back, if I'm honest. So,
I'm officially announcing my resignation on the pod. No, I'm not really. I'm all right.
The final episode ever of Logicast.
Oh dear!
But, it is quite fortuitous that you're here today, John, because our guest is not. So we were going to be joined by a guest from the AWS Community Builder Program, but that guest is AWOL. So today you have just got John and I.
My
John,
deepest and sincerest apologies.
So John and I will muddle through as we have done in the past. We never used to have guests when we first started the podcast, so it's just like the olden days back in Season 1. But here we are in Season 3, Episode 9. And regulars to the podcast will know that once a week I collate a list of AWS news, which I share via my weekly AWS News Roundup newsletter. And then John and I pick a subset of the articles from the newsletter that we'd like to dive a little bit deeper on in the podcast. So we've got such a set of articles for you this week. And the first one, it's not so much of an article, more an announcement, really, about a new feature for AWS Systems Manager. And it is the fact that AWS Systems Manager Parameter Store now supports cross-account sharing. So, John, perhaps give us some definitions, Parameter Store, what it does, and why the fact that it supports cross-account sharing is a good thing.
I haven't had to work like this for a while. I normally get to just jump straight in because we've got other people to talk, but now I have to fill the air, and I'm not sure how I feel about this.
Yeah, you got 5 minutes per article, John. Remember, that's the
I know. We're going to struggle. All right, definitions, because that will fill some dead air. So, Systems Manager. What's that? Systems Manager is a loose collection of roughly related tools that help you manage your infrastructure. We use Systems Manager at Logicata quite a lot because it's got Patch Manager and maintenance windows, and these are great ways of making sure that your EC2 instances are patched. Brilliant. There's a whole bunch of other stuff for managing loads of servers. There's Fleet Manager and Node Manager, and it integrates with Inspector and kind of all sorts of cool stuff like that. Brilliant. One of the parts of Systems Manager is Parameter Store. Now, that isn't specific to EC2s or physical kit or servers and kind of all the rest of it. That's kind of available everywhere to the extent that there's an HTTP proxy server available for Lambda, because it's a brilliant way of just keeping parameters rather than baking them into the environment variables. And whilst that's kind of okay, it means that to change them, you've got a lot more fiddling, maybe a redeployment, kind of all that jazz. But if you do it through Parameter Store, you don't. Brilliant. And it'll integrate with things like CloudFormation as well, so that you can, at deploy time, you can look up a parameter from Parameter Store, and it's great. It's nice. I like it. Big fan. Always have been. Excuse me. One of the primary issues, though, and it's not an issue per se, but one of the limitations of Parameter Store was it didn't support cross-account sharing. Now, what is that? Well, if you have, say, a golden AMI, is the example they use, and you want to be able to share that AMI across various accounts because you've built it in your build account and then you shared it to your development account and your staging account, your production account. You can share the AMI across accounts absolutely brilliantly. And how do your deployments know which AMI to go and get? Well, they look up the parameter. Only they can't, because you can't share that. So you have to have... Excuse me, I am dying this morning. So, yeah, blowing Carl's ears out there. Excellent. I have to get cheaper headphones that aren't so good. So why is that a problem? Well, you have to have 4 parameters in each account just to store the same thing, and every time you make an update to that AMI, you get a new AMI number, AMI ID, AMI ID. I'm going to use both to annoy people. You have to go and update all of your parameters, which is a pain in the backside. It's really awkward. It's really annoying. Nobody likes it. Blech, basically. And there's been a number of half-cocked approaches that I've seen, not by AWS, but by me, building things with lambdas so that you can just push the update into various places. And it kind of worked, but it sucked. And that was one of the advantages that Secrets Manager had over Parameter Store, one of the few advantages. because there's been this kind of long running, should you use SSM parameter store or should you use secrets manager? Secrets manager costs money, parameter store doesn't for a basic parameter. It's like 50 cents a secret and it's free for a basic parameter, but secrets manager supported cross region and cross account replication where cross account replication, I don't know if it does regions, I think it does regions, where systems manager parameter store kind of didn't. Secrets manager had scope for much larger parameters. I think parameter was 4K and secrets manager was like 500K. So it was, much larger amount of data. So it was kind of but other than that, you've sort of went, well, okay, secrets manager can trigger lambdas to rotate the password, or I can use an event bridge scheduler cron to trigger my lambda to rotate my password. It's neither here nor there. And what this has done is this has kind of broken down that barrier a little bit and made one of the advantages of Secrets Manager, cross-account replication, no longer an advantage because the competitive tool, even though it's still within AWS, but the sort of competitive tool supports it as well. Brilliant. Lovely. Excellent. And before anyone pipes up in the comments, we have comments on our things, probably on YouTube. Before anyone pipes up in the comments saying, well, why would you put a secret in parameter store? They have an encrypted secret. It's a secure string type parameter. It's still free. That's why you'd use it, because it's free and it's no less secure because it's all still encrypted and stuff. But yeah, like this a lot. I'm a big fan of parameter store generally, especially if it's secrets that you kind of only care about within the scope of your AWS account and now within the scope of your AWS organization, because you can centralize it. Brilliant.
Nice. So it's going to drive more use of parameter store?
Yeah, maybe. There's definitely one customer that I need to tell about this because they've set up a structure for doing this, and it's going to make their pipelines a lot easier. So I just need to go, by the way, you can manage it centrally in this account that we've created for you and then push it out everywhere. So much easier. And realistically, I don't know that this starts to eat the lunch of someone like 1Password or Bitwarden or whoever, because those are much more, those are much more consumer-facing tools rather than engineering tools. But this certainly starts to make life a lot easier.
Nice. Well, you definitely did 5 minutes on that one, John. So I'm hopeful now for the rest of the podcast.
No, we're stuffed on the next one. It's about JavaScript.
You chose it. So let's move on to the next article, which is about JavaScript. This is an article from our friends at InfoQ about the introduction of an experimental low latency runtime for faster, more efficient serverless apps. So AWS has recently open sourced its JavaScript runtime called LLRT, low latency runtime, an experimental lightweight JavaScript runtime designed to address the growing demand for fast and efficient serverless applications. So whilst it's about Java, it's also about serverless.
Script. It's not about Java at all.
I think I've just invented a new thing, Javaless. We need to make a product that we can
quick. Someone's Oracle.
Anyway, so the LLRT is designed to address the growing demand for fast and efficient serverless applications. And what I was trying to say was that you are a community builder in the serverless category. So this should
for now, please renew me.
Right up your strata.
Up my strata. I don't run.
Strasse. It's German for street.
Oh, yeah, no, I don't speak German. Do we have any listeners in Germany? Hello to Germany.
Of course we do. Johannes, he's been a guest twice.
Oh, of course. He doesn't count. Please come on again, Johannes. We miss you. All right. Let's actually talk about this rather than just prevaricating. Yeah, waffling. Waffle's fun. All right. So, why is this a thing? Why is this a problem? Well, this inherently isn't a problem. What problem is it solving? So, excuse me. The cold start problem, as it's so known within kind of serverless compute circles, is the fact that when you first deploy a Lambda, obviously you deploy it to your AWS account, it's not actually living anywhere. The code is in a secret S3 bucket, I think, and AWS kind of has ownership and control of that. When you then invoke said function, they will pull your code from where they're storing it. They will provision a container because it runs in containers. They will provision the environment that it runs in, deploy everything down, and then will execute your function. Cool. That's the cold start because it's not sat there. After they've done that the first time, it will sit on the infrastructure for around about 10 minutes or so. I don't think there's an official timeline, but it's around about 10 minutes, which means your next invocation is significantly faster. Now, I don't have data for JavaScript. JavaScript is a little bit quicker than Python, but the data I've got for Python, just from personal experience, is I've seen a cold start of 3 to 4 seconds, and then a hot start, or a warm start as they're called, of 300 milliseconds. Like it's significant. The difference is significant. Now, there's been a number of things brought out to kind of help in that regard. So you can do provision concurrency. There was another thing that I completely forget the name of now, where if you're getting like sporadic cold starts, AWS will keep things hotter for you without you having to do anything. And that reduced the cold start penalty by like 70%. And this is just kind of more of the same. What this is, though, is a runtime. Okay. And a runtime is what Lambda uses to run your code. You can't use a JavaScript runtime for Python. Obviously, this is for JavaScript. Brilliant. Why is it low latency? Why is that experimental? So up to 10 times faster startup and 2 times lower cost, because if it's starting up faster and it's running faster, it's not running for as long, and you pay for how long you've been executing your code, which is, that's a thing. It's absolutely a thing. It uses QuickJS, integrates with Lambda and the V3 SDK. All these are good things. Built in Rust, because of course it is, and you have to talk about it being built in Rust, because half the job of a Rust dev is to talk about Rust. Why have they open sourced it is a more interesting question. And I think, so there's a bit in the article talking about this. There's a couple of limitations to the runtime. Is you have to bundle everything into a single .js file, which means it's faster because it's not doing cross-file lookups and kind of all the rest of it, which is great. But that's a limitation because of how your bundling has to work. And then the next thing is, I'm basically saying it seems like it's for glue type lambdas, and that's quite a lot of them. But why have they open sourced? This is my question. And I think the last thing is the last quote kind of answers that, is because it shows promise but needs more stability, support, and real world testing before you can recommend it for production use. And that's kind of where I think AWS has gone with this. They've gone, okay, so we've got this thing, let's open source it and let's work with the community, or get the community to help us to kind of shove this over the line and make it much more production ready. And then in theory, all of the nice quality of life tools that we have for bundling things like TypeScript down into JavaScript and all the rest of it just kind of come in the fullness of time.
Definitely seems like a mixed reaction from the community. Not the various comments that the InfoQ guys have pulled through. Not overly positive. Not the warmest reception to a new feature.
No, but JavaScript frameworks. This isn't a framework, but new features for JavaScript come out with the phases of the moon. So
Yeah. One to watch for the future. See how the community embraces it and develops it and pushes it over the line, as you say. So our next article is from the AWS DevOps blog, and this one is all about best practices for managing Terraform state files in an AWS CI/CD pipeline. So Terraform, of course, being the HashiCorp infrastructure as code. Best practice for managing your AWS infrastructure is to manage it with code, whether that's CloudFormation or Terraform or something else. But if you're doing it with Terraform, then the management of the state file is an important aspect. So, John, walk us through the best practices for managing Terraform state files in AWS.
Just forbid anyone from doing anything with it ever.
Lock it away.
Yeah, it was the Kelsey Hightower thing. I just come back to this every so often. There's a GitHub repo from Kelsey Hightower. It's called No Code, I think. The best way of delivering anything is to just do nothing. Don't ship anything. Don't make any edits. You can't get anything wrong that way. Brilliant.
That's a policy that I embrace in life, not just in IT. So.
Yeah, do nothing. You can't get it wrong that way.
Yeah. It's still wrong, though. Still wrong.
Yeah, probably, yeah. All right, let's do a couple of definitions, because not everyone wants to be familiar with Terraform. So, Terraform, as Karl says, infrastructure as code by HashiCorp, written in a JSON-like language. It's called HCL. It's JSON-like syntax. It's JSON, but a bit less horrible. How does it use this state file. What's the state file? Well, the state file is Terraform's understanding of the state of the world as it left it with regards to that specific configuration. So your Terraform config could have a VPC and some subnets and some route tables, some S3 buckets maybe, an auto-scaling group, and kind of all the rest of it. Right? Everything that Terraform creates, it does, and then it records the state of that in a state file. Cool, excellent. Then when you go to do another run or a plan or whatever in the future, it will compare the state of reality with the state file to make sure that something hasn't happened outside of its control that you need to know about. And if that has happened, it will show up, by the way, all of these things have changed outside of the scope of Terraform. I'm going to go and blow them away now, but you should know about them in case you want to go and, put them back. And this is where you do a plan before doing an apply so that you kind of know about these things and can handle it. Cool. How do you handle the state file? Why is handling the state file important? Well, you can have the thundering herd problem. I don't know if I'm using the right term there, but it's what I'm going with. The last in wins, which was the term that our guest last week actually mentioned. The last right wins. If multiple people are working on the same set of Terraform code using the same state file and deploying at the same time, if you're not handling that properly, then you can overwrite each other and Terraform gets off a right big mess. And just the last state of things wins. That's a problem potentially, which is kind of why you need to make sure you're handling things properly. And what are the options for that? Well, you don't have to put it in a remote backend, but you really should, because that way you can have a shared state file rather than everyone having their own local copy, because that's generally bad. Remote backend on S3. AWS is recommending using S3, and to be honest, if you're deploying things into S3, into AWS, or you're interacting with AWS, then you should just use S3 as your backend because you've got no reason not to. Obviously, if you're using another provider and you're not interacting with AWS, then maybe S3 is not the best thing to store your state files in, but other storage methods are available. Use a remote backend generally. HashiCorp provide Terraform Cloud for this reason, so they have their own centralized remote backend. And then the next option is, in addition to using an S3 bucket for managing the files, you can use DynamoDB for state file locking. Now, I'm not personally an enormous fan of this. Why is it a thing? Well, in the same way that you might want to lock database records so that you have your exclusive read so that no one can modify it whilst you're reading from it, for instance, what this does is this prevents anyone else from interacting with the state file whilst your deployment is running. Okay, fine. I can see the logic of that. Personally, if that's starting to be a need that your team has, I would argue that your Terraform configuration is bloated and you need to break it down into multiple smaller configurations, because your deployment shouldn't be running for so long that you're queuing up things behind it to just get things running. I think that locking is a bad solution to that problem, and that you should be breaking things down into smaller segments. But that's the next option. You can absolutely lock it so that if you've got a particularly big team, perhaps you could still have that, even if you've got very small modules of code, or if you've got this kind of legacy setup where you've got, here is our production code, here is our staging code, and all of your Terraform is one set of configuration. Generally, that's bad, but if you're in that situation, then locking is kind of necessary. And that's kind of it. Really, those are the two things, is remote states and lock the states if you really have to. But like I say, I've never found it necessary. AWS does go on a little bit to sort of give you a few more options. And it says, for your S3 bucket, use bucket policy, so you're restricting who can get to the state file. Now, that's important because it can have secret values in plain text in the file. So you should absolutely be encrypting it and restricting who can get to it. They're not the easiest thing in the world to read, but you could go and find passwords and things in it, if you were creating databases and supplying a password. And the next one, it's also saying use a lock ID for the primary key for your DynamoDB table. And that means you always get a new record. Okay, fine, whatever. And then if you're using multiple accounts for your various deployments, have the bucket in the account that it is deploying to, so that account is aware of itself. I'm really dying this morning. And that's a thing as well, such that you're not doing lots of cross-account lookups for managing state. And again, I can see the logic of that, but depending on what your environment looks like and how you're doing things, sometimes centralizing your state is useful. We've certainly done that with a few customer deployments where the Terraform was looking across multiple accounts. Because you do something like setting up Transit Gateway, for instance, you put Transit Gateway in one account and then you put attachments in all the accounts that it needs to talk to, and you do route table changes in all those various accounts as well. Where the hell are you going to put the state file for that? Well, you could have multiple configs for kind of each one, but then the share and accept gets quite messy, and you're better off putting it all together, I've found. So you just kind of got to pick somewhere and put the state file there. And centralizing the state file in that case is a reasonable idea. So yeah, those three extras from AWS are reasonable examples, particularly the third one, because if you are deploying to production, your production deployment user shouldn't have access to development and vice versa. So I can see the logic there, but it's case by case for that.
Then they've got what do you do?
Try and avoid using it if I can. I use org formation as much as possible. So it's a Terraform specific problem, right? Because if you use something like CloudFormation, it doesn't have a state file. The stack is the state, and the stack lives in the account you've deployed it to. So it's a unique problem to Terraform and Terraform-like tools like TerraGrunt, which wraps around Terraform, or OpenTofu, which is the open source version. It's a unique problem to those sorts of tools that operate from outside of the cloud. If you're operating from within the cloud, and I don't know if Google has one, but Azure certainly uses PowerShell DSC, domain-specific configuration, so you can operate from within the cloud, like CloudFormation and CDK, then it's less of a thing. But people like Terraform. I like Terraform. It's one of those nice things that will be able to talk to lots of different things at the same time. I mean, we use Terraform for deploying our Datadog monitors and things because it supports it. So we can go, I can do a bunch of lookups from the AWS account I'm caring about, and then I can pull the data from that and go, okay, and now you care about hit in Datadog over there. And actually, we use parameter store for storing things like the API keys for Datadog. So it's this nice sort of cyclic setup. But yeah, it's like I say, it's case by case. What I tend to do, remote state, because obviously don't have a local state. I've never bothered with state file locking because, like I say, maybe it's because I've worked in small teams and it's never really been necessary, but I've never found it to be a problem. And I've never seen a platform team big enough that it would be a problem. Like the biggest platform team I've ever worked in, there was 8 of us or something, but the infrastructure we were working was so enormous and the Terraform was broken down to a fairly low level, so it kind of didn't matter. Absolutely encrypt where you're storing your state files because it can have some stuff in plain text. Make sure that you're restricting that. But this cross account thing, depends on what you're deploying. Like I say, if you're deploying stuff that by its very nature has to operate cross account, then you can't exclusively say that the state file lives in the account that it's related to. But by and large, try and do that.
Nice. Okay. Let's move on to our next article for this week, which is from a member of the AWS community on the dev website. So it's Yan Kui, AWS hero, who's written an article about the best way to migrate Cognito users to a new user pool. So probably need to start with some definitions of what is Cognito and why would you use it. And then he's suggested 3 different options for migrating Cognito users from one user pool to another.
Yeah, I picked this one because I always struggled when I was doing the training for the DevOps Pro exam to remember the difference between a user pool and an identity pool in Cognito, because they both identify users and authenticate users, but they do it for different purposes, and I could never bloody remember it. So every opportunity I get to talk about it, I talk about it to just try and reinforce that, because I'll always forget. So a user pool, it is a pool of users for authenticating users from outside of AWS against your application. So basically you use something like a JWT token typically to sort of say, Cognito doesn't use JWT, but typically another way of doing things is you go off and get a web token that says, I've passed my login and password. I am this person. I am John. Please show me my profile, please. Great. Different from identity pools in that a Cognito identity pool authorizes users to use AWS services directly without having an AWS account. Cool. Right. I can still remember it. Good. Why do you need to migrate users from one pool to another? Well, there's a number of times where you have to. try and avoid it at all costs, realistically, but there's a number of times you have to, because certain settings, you can't change them after you've made the pull. And Jan says this, there's immutable attributes, i.e. attributes you can't change, cannot be changed to mutable ones later. So big example being, the primary key for that user being their email address. You cannot make that a changeable field if your pool is at point of creation say you can't change this. So that's kind of why, realistically. And there's a couple of other reasons as well, but they're less technical and more kind of organization businessy. And then there's the data sovereignty thing, which if you'd asked me about it 3 years ago, I'd have told you to take a hike, and now it's kind of a thing. So, okay, fine. You might need to have users from within the EU held within the EU entirely, as an example. Right, so that's why you might need to do it. How do you do it? Well, there's two options. You add existing users to a new pool, give them a temporary password and say, oi, go log in, change your password. And we've kind of all had that, I think, because it's the approach that people end up taking when they know they've been hacked. By the way, we've changed everyone's password out of an abundance of caution, go change it. So everyone's kind of familiar with that, but it's awful. No one likes it. And everyone goes, ugh, really? And that can cause churn because people go, I didn't even know I had an account there. Bin. Or, really? You can't store my data and I don't care enough about what you're doing. Bin. So that can cause churn. Right. Option 2, there is a trigger built into the authentication flow whereby a user logs in and then you get a notification. You can do stuff in EventBridge that says, by the way, a user's logged in. Cool. Now we can go and migrate them into the new one. We can pull them across because they're pre-auth and we know about them. We know who they are. And then we import them across. Great. That's less awful, but it still sucks because you might have users in your system that will never log in again because they have churned. You just don't know that they've churned, basically. So that's a little bit annoying, and it can take a very, very long time. And in truth, it can just run for in perpetuity. And you have to have this Lambda code sitting around there to handle that forever, which you don't want to do. So option 3 is, option 3 we'll talk about in a minute. Most people do both of them put together, whereby you run the migration process for 6 months. And then after 6 months, anybody that hasn't been migrated, you force them to with this password kick, effectively. And that kind of works. Option 3, go passwordless. Hallelujah. Passwords are so old hat. I hate them so much, to the extent that I have a password manager for work and a different one for home, and I try to get my parents on it, my siblings, and kind of all the rest of it, and passwords suck because they're so insecure, they're awful. You have to have these ridiculous 16-character alphanumeric hexadecimal passwords with, have you got a special character? Have you typed it with your left hand? Have you done the Freemasons handshake? Ugh. Just ugh. And passwords are horrible things to have to manage from a systems perspective as well, because you have to make sure that you're encrypting them and storing them properly and only storing them for as long as you have to, and you don't get hacked, and so on and so on and so on. So go passwordless is option 3. And users of Slack will have seen this. Whilst they have a passwordless option, it's a magic sign-in link. So you put in your email address, they email you the link, and so long as you're on the relevant device, you go, this is me, click the link, and it opens in your auth, and you're in. Brilliant. Love that. Love that so much. And that does also kind of cover you for that sort of thing, because you're not holding users' passwords anymore because they don't have one. Great. And then you can use federated logins as well through, log in with your Google account, and then Google does the auth for you. So whilst there is still a password involved, you never see it, you don't care about it, you completely offloaded that. Brilliant. And apps and things I've worked on before, particularly when it was Greenfield, I had the very strong view that passwords were like holding toxic waste. You don't want to do it if you can possibly avoid it. So let's not. Let's just do federated logins and move on with our lives. Because between Google, like an email address, Facebook account, Apple ID, I think you've covered almost everyone on the planet that has access to the internet. They'll have one of those things. Okay, let's just use one of them. So yeah, how do you do it? Those 3 options. Which one should you do? Go passwordless, because you can turn this really annoying thing into a new feature development. And Jan is kind of saying the same thing as well.
So if everybody goes passwordless, is that the death knell for password managers? Or are we always going to need some passwords for something?
I mean, I don't know. Like, your MacBook has still got a password, even though once you unlocked it the first time, you could then use your fingerprints and things. Passwords are a funny one because passwords, and we're not American, but passwords are covered under the Fifth Amendment against self-incrimination. Your biometric data is not. So, note to anybody that doesn't live in America, what this basically means is turn off any biometric auth, Face ID, Touch ID, whatever, when you go through the customs line at America and in the US, and they can't force you to unlock your phone. They can if it's on your fingerprint. So, pro tip for avoiding your stuff being scanned. But other than that, passwords are probably on the way out, I'd like to think.
Watch this space.
For more tips to annoy the TSA.
I'm not necessarily recommending that anybody implements these tips because we can't guarantee that you won't get locked up by doing what John says.
They just can't force you to unlock your phone, but they might still arrest you.
Proceed with caution. And proceed we shall to our final article for this week, which is from the AWS Training and Certification blog, which is all about learning AWS Cloud skills based on your own unique learning style. So I know this one, you got a bit of a controversial view on this one, John.
It's not controversial in the slightest.
But obviously AWS has a lot of different ways for you to learn about AWS. And what this article is attempting to do is to point you in the direction of resources which could suit your own specific learning style. And it outlines the 4 different learning styles, which are visual, learning by seeing and reading; auditory, you learn by hearing and conversing; kinesthetic, learning by doing; and writing, you learn by writing. I'd love to know which of those learning styles applies to me. I'd probably say all of them, depending on the subject matter. And
that's the thing right there. That's absolutely the thing. I'm going to cut you off because this annoys me so much. This whole theory that people have learning styles and that one way of learning is better than another for a certain person has been thoroughly debunked. It's a nonsense. It's complete nonsense. It's so pervasive over the last 70 years odd. It's been okay, you're a kinesthetic learner, so you must do it this way. You're a visual learner, so I must draw diagrams for you. Get in the sea. No. There's no evidence to support that at all, ever. None. It annoys me so much. And like a very brief Google this morning, the full page of it was just, this is rubbish, this is nonsense, this is rubbish, this is nonsense, going back decades. And in truth, this idea, and I've got one from the University of Swansea, and I'm not going to try and pronounce that in Welsh because I'll offend everyone in Wales, and I quite like Wales. Basically saying that it persists in education. This is a review from 3 years ago now. It persists in education. It might actively be harmful because people get pigeonholed into, I'm an auditory learner, therefore I must listen to lectures and never do anything else. And then you struggle with it because an auditory learner isn't only an auditory learner. You're just not. And then you struggle with it and you get completely turned off by it and go, oh, I must not be very good at this then, and move on. That's rubbish. It's complete rubbish. Now, I'm all for what AWS have done here, and they've sort of said everyone does learn slightly differently. There's kind of 4 main ways of learning, listening, lectures. Everyone's been to university, been to a lecture. Visual, seeing stuff, again, kind of a bit lecture-y, somewhere in the middle. Kinesthetic by doing, and writing by writing. And that's always the people that say, well, I have to handwrite my notes because that helps me learn. I never had that, but I can see that that's a thing. But it's not exclusively the act of writing that's making you learn that. But I'm all for what AWS is doing because they've sort of said, well, we have loads of different ways you can interact with this learning content rather than just the Udemy lecture style. Other lecture services are available, but just the lecture style that Karl, you and I have kind of got on reasonably well with because that's the old-fashioned way of doing things. So I'm all for what AWS have done here by saying, we recognize that people learn differently. So we have the lecture style, we have Cloud Quest, we have labs, we have so on and so on and so on. Brilliant. But the idea that people have learning styles, it just annoys me because I really would have liked AWS to have put some sort of disclaimer at the top to say, there's no one size fits all, and honestly, there's no one size fits one person. If you think you're an auditory learner, you should still try and build stuff in labs because you will also pick things up doing it another way. And I really would have liked to have seen that.
Well, some good feedback for the article writers there, but yeah, no question that having these different resources available to us will help us along our learning journeys. But that's really all we have time for this week. So that was season 3, episode 9 of Logicast with myself, Karl Robinson, and John, as always, Goodall. Well done, John. We've made it to 35 minutes without a guest. So pat ourselves on the back later. Thank you for listening. If you enjoyed the podcast, tell your friends. You can download the podcast from wherever you get your podcasts. And if you'd like to see what we look like when we're talking to you, you can check us out on YouTube as well. We'll be back next week with another episode of Logicast for you, hopefully with another guest from the AWS community. But thank you very much for listening, and we will see you again next time.